Hi, good afternoon. This is Mr. Cassidy, and today we're going to be going over Chapter 5, Lesson 1, which has to do with angles and parallel lines. Let's go ahead and get started. Our goals for this lesson are these. Number 1, to be able to name the kinds of angles formed by parallel lines. And number 2, to be able to find a missing measurement based on angle relationships. So number 1 is mostly vocab related. Number 2 is actually measurement related. Let's begin. Second, before we begin, I want to readdress our core beliefs. We talked about them briefly recently, but let's restate some main beliefs that we can have for ourselves in math. Number 1, growth mindset matters. Those who believe that they can get smarter do get smarter. Number 2, mistakes make the brain grow. If you make a mistake or two in this video, or 3 or 4, that doesn't matter. The goal is to learn. Number 3, effort, trying your best. That is what's most important. Your process in learning is more important than just getting a correct answer. Let's try to follow those as we go through this lesson today by trying our best on each of these questions. During the lesson, you're going to want to take notes. Here are a list of words that we're covering, and each are pretty important. And since it's a whole lot of words, you're going to want to write down a rough definition, and that just means in your own words what they are, and draw a visual for each of these words. That'll help you be successful when you get to questions about them. So please make sure you're copying down notes as you go. You can find this graphic organizer on on Google Classroom, so you could print it out at home, or you can just copy it in your math notebook. Let's begin with an angle. An angle is a measurement about the intersection of two lines. Let's take a look at what that means. So here you've got two lines in blue, and where those two lines intersect forms an angle. And an angle is the measurement of how wide the two lines are. If you have any two lines, like a counter and a sink, they form an angle. The angle is measured in degrees. So here you see these two lines. They're measured by this device called a protractor. By setting up a protractor right, you can see how wide the two lines are spread apart. Here we would start counting at 0 and go up along this arc to see where the other line falls through. You can see that's at the number 75. The tiny lines are additional numbers. And 75 would be marked as the measurement of this angle. It's 75 degrees. You may remember covering angles like this and angles like this in years past. The idea is these angles show how wide and spread apart the two lines are. The one on the right is wider than the one on the left, and a number that we give that is the measurement of that spread. So for instance, 75 degrees is a measurement of an angle. I'm just restating this as this is like a main idea that we need to know before we can actually analyze angles. So notice what happens when two lines intersect. How many angles are formed here? So you should see 4 angles. Here we have 1, 2, 3, and 4 different positions that could be measured. In this case, and in most math books, you're going to see numbers for angles. So you might see a number 1, 2, 3, and 4. Or they might use letters. They might put angle A, B, C, and D. How you'll see this marked in a math book is they write the symbol for angle, which looks like a less than symbol, and a letter or number. So angle 1 would look like this. That reads angle 1. Now, if we're going to talk about the degrees, you may see your math book write M angle 1. What that means is the measure of angle 1. And so if we put measure of angle 1 equals, I don't know, 65 degrees, we're talking about how wide that angle is. All right, let's carry on. So our first definition that we need to understand is supplementary angles. A supplementary angle adds up to 180 degrees. That means two angles that together Their sum is 180. So for instance, back to our original picture of an angle, the first angle we looked at here was 75 degrees. So the supplementary angle, if we just extend this, would be whatever adds up to the rest at 180 degrees here. In this case, it would be 105 more degrees to get to 180. Also notice this, that 180 degrees is formed when the two angles next to each other form a straight line. Go ahead and write down your definition for supplementary angle, and let's look at this final, maybe use this as your picture. Notice 120 plus 60, when we add up these two corners, we get 180 degrees. Here's what a question might look like about this. A math question might be like, what's the supplementary angle of the angle in the picture? Well, to set that up, I'm going to say, well, the one I don't know is x, and x plus 40 has to equal 180. So what plus 40 equals 180? We could subtract 40 from each side, and we would get x is 140 degrees. 140 degrees, which is going to be a really big angle like this. If we had an 140 degree angle, it would add, and we added the 40 degree angle, we would get a straight line, or 180 degrees. It's sort of like the difference between 180 and the one that's missing. So now it's your turn to check. Problem A. What would be the supplementary angle for 35 degrees? You should have said 145 degrees. That's right. 145 degrees plus 35 degrees equals 180. How wide would an angle be that's supplementary to 65 degrees? Well, you should have asked yourself what plus 65 equals 180 degrees. And when you solve that, you get 115 degrees. All right, moving on. Now, we need this idea of supplementary in a little bit, but for now, we're going to look at our first definition about angles. These are called vertical angles. Vertical angles are formed directly across from each other. What I want you to notice that this is sort of a giant letter V where these two lines are meeting. That helps me remember that where two V's are, I have vertical angles. In this picture, angle 1 and angle 3 are the vertical angles. So what I imagine is this red dot is the center of a table. Person 1 sits across from person 3. They're the ones across from each other are vertical. So what we're looking for is a pair of angles. Angle 1 and angle 3 are called vertical. Now, angle 2 and angle 4 would be a second pair of vertical angles. Now, here's why this is important. We already know a straight line is 180 degrees. Let's say that this was 75 degrees at angle 1. Well, we could figure out, because angle 2 is supplementary, that 95 degrees, I think that's right. Let me double check my math. No, maybe 105. Yeah, sorry, bad math. 105 degrees would be supplementary. Well, notice if we kept going along, now I'm going to look at this straight line, the green line. Well, the next one would have to add up to 180. So this would be 75 degrees. And finally, our last one over here is 105 degrees. Here's what this means. I'm going to mark them. With one arc is the 75 degree angle, and two arcs is the 105 degree angle. Notice that angle 1 and 3 are the same measurements. They're both 75 degrees. Angle 2 and angle 4 are the same measurements. They're both 105 degrees. So vertical angles are also equal to each other. So the partners that are across from each other at an intersection form the exact same angles on the other side. I want you to try one. So first, name the vertical angles based on their letters here. You should have said the angle A and C are vertical because they're exactly opposite each other or across from each other if that was the center of the table. Great. How much is angle B? What is the measurement here of angle B? You should have said 47 degrees because 47 degrees is opposite. Its partner would be B. And so we can tell that B must have the measurement of 47 degrees. Now, based on that, how many degrees? What is the measurement of angle A and angle C? Remember, both of those are going to be partners that are the same. So what is the measurement for angle A and C? Remember, this is a supplementary partnership. So you should have taken 180 and subtracted 47 to get 133. Both of those corners are 133 degrees. So for those who are struggling, it's okay to make mistakes. Let's review what's important here. The angle partnerships are across from each other, and we call them vertical. Last, once we know one angle, we can find the others because they are supplementary. So once we know one is 47, we can find angle A because 47 plus angle A will equal 180 degrees because they form a straight line, which is always a half circle or 180 degrees. All right, moving on. Our next idea is a bit more vocab. Parallel lines are lines that never touch. Lines that will never touch. And so here we have two parallel lines. We have M and N, and we can abbreviate the word parallel by drawing two lines like this. This means that line M is parallel with line N. Now we have a special name for line L. I know we covered this briefly on Thursday's lesson. Line L is called a transversal. So please add to your vocab. The idea of a transversal is just a line that crosses two parallel lines. Technically, a transversal can cross any two lines, but for the most part, the math we'll look at, it'll just be crossing two parallel lines. So line L is the transversal. Pause and copy that. Draw it in your notebook as well. This can be a little tougher when the parallel lines are in a different direction, because a lot of times you're going to see math books that look like this on the left. So I want you to analyze the drawing here. Notice parallel is usually marked with little arrows. So that single arrow sort of means those two lines go in the same direction but will never touch. So first, which two lines are parallel in the second drawing? Great. And which line is the transversal? So you should have said that line A and B are parallel. And you can tell because they have this little arrow here. Next, you should have said that line C was the transversal. Awesome. We need to know these words because next we're going to talk about the angles formed by these lines. So the first key vocab here for the angles are interior angles versus exterior. So interior are the set of angles between the parallel lines. In this case, the angles 6, 5, 3, and 4 are all interior angles because they're between lines M and n. Next, we have exterior angles, and the exterior angles are formed on the outside of parallel lines. In this case, angles 7 and 8 are exterior, and angles 1 and 2 are also called exterior. Go ahead and pause and write the definitions for interior versus exterior angles and draw each one. Maybe use shading or coloring, like I might put some yellow highlights on the interior or green highlights or colored pencil to mark the exterior. Now it's your turn to test. Take a look again. Remember, angle line A and B are the parallel lines. Go ahead and answer the couple questions you find here. Awesome. Moving on. We have a tiny bit more vocab to cover in this video lesson. Alternate means opposite sides of the transversal. Remember, L is our transversal. So an alternate angle would be an angle that's on the opposite side. For instance, 7 and 8 are on opposite sides of it. 7 and 8 are alternate angles. Our goal is to be able to find these alternate angles. So, your turn. Answer the question here. Okay, moving on. We have to put that together. Alternate interior versus alternate exterior. Alternate interior means opposite sides of the transversal that are on the interior. One alternate interior here would be the angle 3 and its partner, angle 5. Sort of like vertical angles have partners, alternate interior is a partner. So my first example of alternate interior is angle 3 and angle 5 because they are on opposite sides of this transversal, but they are between the two parallel lines. Can you name the other alternate interior angles in this photo? You should have said angle 6 and its partner, angle 4. Those are the other pair of alternate interior. Our second definition here is alternate exterior. So alternate exterior again means opposite sides of the transversal, but on the opposite outside of the parallel lines. Let me change colors here. So, angle 7 has an alternate exterior partner with angle 1. Notice they're both outside the parallel lines, and they're on the opposite sides of this transversal that's going through them both. So, angle 1 and angle 7 are alternate exterior. Can you name the other alternate exterior line? You should have said angle 8 and angle 2. Awesome. Moving on. It's now your turn. Answer the questions that follow about alternate interior and alternate exterior angles. Our final definition is called corresponding angles. Now imagine I've got a person here and he's walking down the street. Here's my person, he's walking, boop, 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 and he comes up to this corner. This is like on the map, we're on Bidwell, he's coming up to the corner. Angle 1 is the first thing on his right. Say it's a gas station here. Okay, now imagine my person keeps walking. Boop, 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 boop. And they're walking down the transversal and boom, they get to a parallel line. Well, here is angle 5 is in that first right-hand corner spot. And say we've got another gas station. Sometimes you see this, right, in real life. Driving, it's almost like the same exact intersection. Angle 1 and 5 are in the same location or corner. Notice they're in the bottom right-hand corner. So when we talk about corresponding angles, what we mean are angles in the same location. Go ahead and write that vocab down. And last, just to check your understanding, name the corner that corresponds with angle 3 in the top intersection. You should have chosen angle 7 because 3 and 7 are in the top left. Imagine this is, if it helps, some people always struggle with this, it's okay. Imagine this as a clock or something, or a room, and we just put the same box around this one. What we need to do is be like, okay, top left of the four square and top left, those are the same corner. To double check understanding, what would be the corresponding angle of angle 2? What's its corresponding partner? You should have said angle 6 because it is in the bottom left. And it's in the bottom left of the other group of angles. So those are corresponding angles. Now, why is this all important? These are all just different vocab ideas that have to do with congruence. Congruence means this equal measurement. So remember we talked about how to measure an angle earlier? Like the measure of an angle is, 75 degrees. Well, any congruent angle will have the same measurement. Here's why that's important. We've learned about vertical angles. Well, vertical angles are congruent. So here, angle 7 and 5 would have the exact same measurement. If one of them is 120 degrees, the other is 120 degrees. You can see a lot other examples of vertical angles here. Next idea we covered was alternate interior. Well, alternate interior angles with parallel lines are congruent. So angle 6 and angle 4. If angle 6 is measured at 50 degrees, so is angle 4. Next, alternate exterior angles are congruent. So angle 2 and angle 8 would be an example of that. Those are alternate exterior, 2 and 8. They're on the outside of the parallel lines and they're opposite sides of the transversal. Those two are congruent. They're going to be a partner pair. So if angle 2 is 50, angle 8 is 50 degrees. And last, corresponding angles are congruent. So my example of that would be angle 3 and angle 7. If angle 3 measures something, angle 7 measures the same thing. And our last partner I haven't talked about is angle 1. What you should draw perhaps below all your notes is this main idea. All we need is one angle in order to figure out all of the rest. Let me explain. Let's say that this is 45 degrees. Well, based on the fact that angle 8 is 45 degrees, I can put 45 degrees at angle 6. I can put 45 degrees at angle 4. And I know angle 2 is going to be 45 degrees. How about angles 7, 5, 3, and 1? Well, we can use the rule of supplementary angles to find the rest of them. So if angle 8 is 45, I can label all those orange ones as 45. The yellow ones have to be, let's see here, 135 degrees, right? Because those two add up to 180, which means angle 5 is 135 degrees based on vertical angles. The alternate interior here is 135 degrees, and the alternate exterior is 135 degrees. We can fill in every single one of these measurements just based on one. And now it's time to test that. This was our second goal of the lesson. So first, if angle 3 is 115 degrees, I'm going to fill that in for you. That's this one right here, 115 degrees. Find the measurement of angle 2. How could you tell? Angle 2 is also 115 degrees, and you should be able to tell because they are vertical angles. And we know that that is one of the kind of partners that are congruent. How about angle 1? What's the measurement of angle 1? How could you tell? Well, you could tell it a few ways now, but angle 1 is also 115 degrees. And you might be able to tell by two different methods. First off, it's corresponding with angle 3, and its alternate interior from angle 2. And again, those are partners that are going to match. Now find angle 5. You should have said that angle 5 is 65 degrees. How could you tell? Well, now we could tell because it's supplementary with angle 1. All right. This will take practice, and having all those vocab words written down really helps, and looking at the pictures and drawings will make sure that you understand this well. So let's reflect on our goals. First, number 1, are you able to name the kinds of angles formed by parallel lines? Imagine we drew some. And again, people who are going to be building things, drawing things, they may not know every single name of these angles, but they're working with them daily and they understand this relationship. So, can you name some of the corners here and how they relate to the other corners? The second goal would be to find a missing measurement. So if you know that one corner is, I don't know, 130 degrees, would you be able to name every other corner's degrees here? All right. With that said, I thank your minds and your hearts, and I wish you a good math afternoon. We'll carry on from here, analyzing angles and relationships next lesson. Bye.